Assalamu alaikum everyone. This is Fahad Ansari and I'm here to help you conquer chemistry. In this video we'll be looking at the basics of atomic structure. So as we all know, everything is made up of atoms, and atoms mostly consist of empty space, but within the center of an atom we have a dense nucleus which contains most of the mass of the atom. This nucleus consists of two subatomic particles, namely the protons and the neutrons. And surrounding this nucleus, in fixed energy levels known as shells, we have a third subatomic particle which is known as the electron. Now let's take a look at some of the physical properties of protons, electrons, and neutrons. So protons and neutrons have a relative mass of 1 unit. Electrons, on the other hand, are much smaller than either protons or neutrons. We cannot say their mass is exactly zero. It's negligible. So we write it as being 1,840th of the mass of a proton or neutron. We talk about charges. Protons and electrons have the same magnitude of charge, but with opposite signs, protons being positively charged, electrons being negatively charged, and neutrons do not carry any charge. Now, the reason why we use the terms relative mass and relative charge is because the actual mass of a proton in kilograms, which is the SI unit for mass, has a very small value, and the same can be said about the charge of a proton. It has a very small value when you measure it in the SI unit of coulombs, which is for charge. So instead of using proper mass and charge values, we just talk about relative mass and relative charge because it just makes things easier. So protons and neutrons are found in their fixed positions within the nucleus. Electrons, though, keep moving about around the nucleus in their energy levels known as shells. So despite the fact that many years ago Greek philosophers had theorized that everything is made up of atoms, despite the many advancements made until this day, scientists can only tell where electrons probably will be at a given time. They cannot exactly be sure. But I hope that one day we can actually tell where electrons will be at a given point in time, but that's not what we can do right now. So, talking about the charges and the masses on these subatomic particles, let's say we pass a beam of these subatomic particles through an electric field, which is basically a positive plate and a negative plate, and the field between them is our electric field. So if a beam of particles passes through, now there are three options. Either the beam of particles could be attracted towards the positive plate, or it could be attracted towards the negative plate, or it could just go straight ahead undisturbed. So if it is attracted towards the positive plate, these are definitely going to be electrons, which are negatively charged and are attracted towards the positive plate, the oppositely charged plate. Protons, being positively charged, will be attracted towards the negative plate, and neutrons, carrying no charge whatsoever, will go straight through undisturbed. And you can also see that the deflection experienced by the electrons is much larger than the deflection experienced by the protons at the same point. At the same point along the electric field, the electrons experience a larger deflection, and the reason for that is because electrons have a much smaller mass. Protons are much heavier, so they're more difficult to deflect. Now let's talk about elements. Now, elements are substances that cannot be broken down into simpler substances by chemical reaction, right? So when we talk about elements, we say that they consist of only one type of atom. And when I talk about one type of atom, basically means atoms with the same proton number. Now, the number of protons in the nucleus of an atom basically defines which element the atom belongs to. If you change the proton number by just one, you're going to change the element that atom belongs to. Now, there are multiple ways of representing the numbers of subatomic particles in different types of atoms. So let's take a look at an example. So over here you can see that we have represented an atom of the element helium with this chemical symbol He, which is used in chemical equations and formulae. All right. And we have two numbers over here. We have a number at the superscript, which is the nucleon number, symbolized by A. Now, nucleons, basically the nucleon is the collective term for protons and neutrons, right? Basically the particles in the nucleus, that's why we call it nucleon number, right? Now this is also known as the mass number. And the reason is that most of the mass of the atom is found in the nucleus. Basically the protons and neutrons, the nucleons, are much heavier than electrons. So that is why if you just count the number of protons and neutrons collectively, you get a rough idea of the mass of the atom, because each has a relative mass of 1 unit. Then in the subscript, we have the proton number, which is symbolized by Z. This basically tells us the type of atom or the element that atom belongs to, alongside the chemical symbol, of course, right? So any atom with 2 protons in it will be a helium atom. And for example, any atom that has 1 proton in it is not going to be a helium atom, it's going to be a hydrogen atom. All right. Now, in an atom, the number of electrons is going to be equal to the number of protons, because atoms are electrically neutral. All right. So the total negative charge has to be equal to the total positive charge. So the number of electrons will always be equal to the number of protons in an atom. But what if you have an ion? Now, ions, remember, are charged particles. They carry an overall charge. So there's an imbalance between the total positive and total negative charge. So let's take a look at an example. We have the oxide ion over here. It's made up of atoms of the element oxygen, symbolized by O. Now over here we have an overall charge for the ion, right? We call this the ionic charge. Now over here the charge is 2 negative, which means that we have more electrons than protons, so that the overall charge on the ion is negative. Now 2 negative tells us that if we have 8 protons as given by the proton number in the subscript, then the number of electrons actually will have to be 8 plus 2, which gives us 10 electrons. We have 8 protons given by the proton number, and we have 16 minus 8, which gives us 8 neutrons. This is basically found by subtracting the proton number Z from the nucleon number A. So A is 16 over here, Z is 8, so 16 minus 8 gives us the number of neutrons. All right, so this is the basics of atomic structure, the 3 subatomic particles, the definition of elements, and how you can find the numbers of the different subatomic particles in an atom or ion. In the next video, we'll briefly touch upon isotopes before we move on to electronic structure or configuration in detail. I hope you enjoyed this video. If you did, please give it a like, to subscribe to the channel. Inshallah, I'll see you in the next video.